Welcome back and welcome to lesson 4 in the Houdini Environment Beginner Series. We're going to continue where we left off, and if this is you picking up straight from the last lesson, we were previously inside our LOPnet here in stage. I just hit U to jump up, and now we're going to jump inside the modeling part 1 lesson 4 scattered geometry prep. One cool thing I'll actually show you is this section and this section you can see are both showing the same network. So if I move this box here to this spot, it'll move in this one and then back and forth. This I have so I can see this little lesson slide in one area on the screen and then also move around here. But the cool trick actually is, say I'm going to U to go up while selecting my mouse over this area, which will take me up a level on this object, this network view. So say I was inside LOPS and I was lost and I said, all right, this is cool to know here, but I want to see this area on this bottom right network view. I can drag any node. So say take the box onto this network view, let go, and there we go. And it'll snap me back to this same object, the same location in Houdini. And again, the locations are defined as file paths essentially from the object context and then inside this. And you can see the little name of the node we're going inside is appended to the location. And then when you're using object merges, the location of everything is defined again through these. So that's a basic thing we've covered before, but I just wanted to refresh. All right. So let's get going. This one is going to be a quick introduction to the modeling of each of these shapes for the rock, the stone paver, and the grass plant. We're going to walk through pretty much node by node what everything will do, and then maybe make a few changes, but maybe come back later in videos to add a new prop. So firstly, to start with the rocks, all it is a box, which again here is a primitive. I set the size and the divisions to be different, so I added another division along this side. This axis is x-axis, and these you can set the resolution of the points on this box. And there's no correct way. This is just a way I came up with a rock. I displaced it with a noise, which again we learned in one of the previous lessons, displaces the points of an object along the normals. And now it's doing a vertex normal it's showing me here. But if I compute the normals on points and see what those are, these green arrows, and I plug that, I don't have to plug that into here actually because the normals are automatically computed. But I can put that in here, and then this noise displaces those against the normals. And my viewport's actually going a little slower than I would expect. So the reason it might be is I might be thinking about things outside this network. And the reason for that might be because it's ghosted. So I'm going to go up to here and hit hide other objects. And then it should only think about what's inside this geometry container. So that is a little too slow. Well, we'll keep going. I might restart actually for a cut to do a reset of Houdini and see if that fixes it. So I'll be right back. All right, welcome back. I restarted Houdini and restarted my computer, and it looks like it is speeding up a little bit. So that's one thing. Sometimes Houdini can slow down and just a restart helps usually. And then I'm also going to leave that in the video because I want to show that issues happen, and a lot of the time the way you solve issues, even as simple as restarting your computer, can help a lot. So I also run into issues a lot, and I want you to learn as much as possible. So helping kind of see how I work through those issues, and even issues later with the nodes we'll go through, and I'll leave as many of them in as I can. So to continue, we learned that our normals here from our box are being computed here, but they're also being computed internally by Houdini. So we do not need this normal node. This mountain noise is displacing with a noise the vertices or the points along the normals in both a positive and negative direction, which is what the zero centered is doing. So this mountain here is the same as an attribute noise vector. It's just here it's set by default to V for velocity, and here with mountain it's set by default to P for position. So same node, different use case. And here the zero centered, if we set it to positive, it'll displace only in the positive direction, but I did zero centered just because I liked the way it looked. So subdivide again will give me some more resolution here, and I actually set the subdivision to open subdiv by linear, which if I hit middle control and middle mouse button, it'll reset to the default subdivide. So here, but what I wanted to do was I wanted to add the resolution of the cuts without actually merging or displacing and smoothing the corners. So you see, we keep the original shape. If I template this flag here with this purple, we keep this shape, not with this version because we're subdividing it with this algorithm, but with this other one, we can keep the shape and add the resolution. So that's what we want to do. Again, no right way to do this. It's just the rock I wanted to make. This is the position. Subdivide again. Same method. To add the resolution without displacing those points in between, without smoothing those edges. And we can turn on and off the normals and the point count or point previews here. I then use a UV unwrap, which creates procedural UVs. Whoops. Y to cut. And it just can be toggled on with this button here. So UVs, again, we learned in our lesson for materials. They are 2D texture coordinates mapped onto objects, and in this case, we're using them later for mapping the textures. But you can do lots of cool tricks with UVs. And then here I scale it. So you can see if I middle mouse button and drag up and down, I can change the increment. And it looks like I scaled the UVs very, very small to 0.02. And that was just a value I found in my materials that worked well. So here we can also change the UV scale in this case, or we could change the texture projection scale once we get to the material setup. But there is technically no really correct way to do it with this workflow. If you were doing an asset workflow where you're working in a bigger environment and you need to save out certain assets, you might have requirements for the UVs. But because we're doing basic tiling, dirt, and rock textures, we aren't worrying too much about the actual UVs themselves. We just want something that looks somewhat natural. So again, scale that up. I transform it to make it a little smaller. Poly bevel, which again we've learned in the last video. I think it was the beginner video actually, that we can bevel by a certain distance and we can exclude edges by certain normal angles. And we can add division cuts to our bevel. And this is it. This is the rock I chose to stick with. And then we did this earlier, but I cached it and it looks like I cached a different frame. And again, changing the frame number changes the actual mountain, the noise, and the reason for that is because of this expression. So I had this. I typed a mountain node, and I'm going to delete these two because I don't need them. Put in the position. Let's make it a big position. And then the expression I used was on, I think it was the offset. Whoops. This is again going inside the mountain node. You can double click to go inside, and most of these nodes in Houdini are made up of other nodes. So it looks like the offset on the noise pattern I did an expression for. So let's do offset $F. If I click this left click, it's going to give me 12, which is the frame number. I could also do $F divided by 100. And if I click play, it'll give me a little animation. So it's animating this noise based on this value here. And it's computing that on each frame. So I'm going to delete this channel. And that's essentially what I did here. I think I actually, yep, I did it again here. And then just on these two nodes, and you can see this little green icon is indicating that the nodes are time dependent. So if I disable the time dependent node and disable the time dependent node, then the green icons will go away. So this node will not be recomputed every single frame. But if I enable it again, it's now time dependent, this entire chain. So from here below, and that will be recomputed every frame. And that might not matter for a small scene like this, but you'll see once we get to the house, with the number of operations we're doing and the complexity of the scene, it is very slow to compute one frame, then the second frame, and then the third frame. And that will get more relevant in procedural modeling. You want to be intentional with where you have your time dependencies. So if you can do something without being time dependent, that's usually the way to go. And then you don't want to have to recook everything on every frame, because that is a waste. So we saved our single frame, and it only saved one frame because it's not time dependent. If you do a file cache, it by default will actually be time dependent. So if I did want to save this, it would save, let's say, I'll actually delete this and show you right now, which might happen if you're trying to follow along. So you add a new file cache, maybe you jumped aside and made a new video, or not a new video, a new procedural asset you want to scatter. You click file cache, you don't want a frame range, you want a single frame, click save to disk. And there we go, and we can disconnect this. But if we change the frame, we'll see that our environment, or not our environment, our rock, our cache, is no longer seen because it's on frame, I think 15 it was. So frame 14 it won't be there, frame 15 it will be there, frame 16 it won't. And the reason for that is this is a time-dependent cache, and inside this node, Houdini is actually saving the frame, you can see $F4, to the file name. So when it's reading it back, it's actually looking at the current frame. What we can do is a file cache. Whoops. So that was an example. I accidentally hit, I'm going to hit Control Z. But if you hit L, it'll automatically rearrange all the nodes. So while I was typing, I accidentally hit L. But what I want to do is a file cache. I want to go here. And then inside this file cache, I want to disable simulation. And I want to disable time-dependent cache. And actually, I could disable time-dependent cache, and that will automatically disable the other one. Sometimes you'll have something that is time-dependent but not a simulation. So the frame 48 might not depend on frame 15. And then I don't actually know exactly, but I would assume a simulation, it would force cook. So it would force Houdini to go through frame 1 to 2 to 3 to 4. The other one, it might let you parallelize in a top net if you wanted to, for example, cache 10 at a time. You might be able to cache these 10 frames in one certain process on your computer and then 10 at a different time, because one frame does not depend on the previous frame. So if we wanted that, we would disable time-dependent cache, save to disk, and now if we scrub through our timeline, there we go. Our rock stays still. So I'm going to delete those. That's a quick setup. And then you might want to use a file cache. So as we go through, I'll kind of explain everything because I really want you to understand what's going on. And there, that's all we did. We made a cube shape, added a resolution, displaced, randomized, and saved. We're going to do the exact same thing here, except with a flat cube shaped. So we start with our box, and you can see the size of the box. Again, middle mouse button, 0.1, displacing with a mountain. Again, our time offset. So if I click play, subdivide, again, without actually smoothing those corners, displace with a mountain, again, to give some random noise. Subdivide. This time I did want to smooth this. So I could probably also do that one and it'd be fine. This one does cut into the triangles, so I might actually leave this to change it. Unwrap it, mountain, so add some more noise again. and then scale the UVs similar to how we did with this UV here, and that was just for the textures later. And then I transform it along the Z axis. This rock on this side doesn't necessarily matter because it's not as important to have a correct orientation. But since this is a flat rock, we want it laying flat on the ground, so we'll want it pointing in the Z direction. And then this was saved, but I'll resave to show you that we don't need those triangles. All right, and then for the grass, the next step, what we're gonna do is follow this exact setup. We're gonna take a line and we're gonna place a bunch of copies of that line with their bases here and extending in various randomized angles. We're then gonna add resolution to those lines. We're gonna displace them, and then we're gonna mesh, or we're gonna add thickness to these lines. And we can do thickness either with the render geometry, which here we'll see. So if I right click and zoom in and out, they start thin, they get thick, and then they get thin. We can either actually do that with this geometry, or you can do curves and you can save the width attribute to a curve, which we will not cover this time, but maybe in a different series we'll get to that, or maybe later down the line in bonus lessons. So the way I've chosen to do this, and again, the reason I'm showing you this way is because there's many ways to make something this simple, but the way I chose to do it was to choose a sphere. And the general idea of what I'm going to do is I'm going to create points, which you'll see down here, that have the needed attributes in order to scatter on. So I create a sphere, which gives me this general distribution of points. I could change this resolution, but this won't necessarily matter because later I scatter points on it. So the resolution doesn't really matter because it's not being carried through. It's just being used as a mesh to scatter on. So get the sphere. I remesh this. Actually, it looks like for simplicity, and then maybe just to get some extra variation here. This you don't actually need. I clip it to make it flat, scale it down, and what I probably could do is a match size to set this exactly at 0. And there we go. That'll automatically set it exactly to the origin. I compute normals on the points, which you can see if I display this tag. So this is how I'm creating this little arrangement of points. There's other ways to do this. You could do this with Wrangles, VOPs. You can do it any way, but I chose to do it this way. I scatter points, and here is a new expression I'll show you, but I set the seed to frames, and then for the total count, I set another variation, another expression. So this one is an expression that randomizes, so fit 0, 1, rand. So rand here takes a frame number, a seed, which is currently times $frame, so frame number 51 times 12. It's going to generate a random number between 0 and 1, which is this fit 0, 1. And this fit 0, 1 function takes 0 to 1 and it fits it between 12 and 24. So if I wanted to take this new scatter that I just dropped down, which I'll do again to show you. Say I want to have, all right, I want random points between 25 and 300. What I would do is force total count. I would do fit 0, 1, which is this function here. And you can look these functions up on the documentation, but we'll actually use this one a lot. Rand $f, so frame number, which is the seed. We'll multiply it by, we actually don't have to multiply it. That was just to give variation across different ones. But we'll leave it as $f and we'll fit it from 25 to 300. And then we need one bracket to close this side, and then this one's already closed. So there we go. Now if we left click it, we can see we have 200 there, 95 there, 71, and we can middle mouse button and see the exact number of points. And this relaxed iterations will smooth the points away so they're not as close to each other. But you're welcome to leave that on or off. And there we go. And this idea we're going to use a lot, actually, and we're going to be randomizing by frames because this little timeline is an efficient way to set a seed without having to go back and change a node or any kind of value. So there we go. That's the points we created. And now the important thing is we have this normal attribute that was transferred automatically from here. And we don't actually need this because it does it intrinsically, Houdini, but this is good so you always know what those are. And for example, actually, again, I'm trying to teach you exactly how Houdini works, so we might be a little more in depth than just a basic tutorial. So say I wanted to scatter here, but I want to create a different normal attribute to transfer. I can do that with v at n equals, and I can set with curly brackets my normal vector. So 1, 0, 0. So x, 1, y, 0, and z, 0. And there we go. Now we have a positive x vector. You can see nx is set here, and that's transferred through our scatter. And now, I'll cover this later, but if we jumped ahead, you can see our grass is aligned in this direction. So this normal is defining the position of how it's being scattered, and there's actually two ways I create the blades later. But for now, we're going to use the sphere's normals, which was a helpful way to get this cone shape, and we're going to use those to scatter. So then the two ways you can create points or extend these points to create the lines is you can either copy a line to the points. Again, this is that Z orientation we learned about earlier. Or we didn't learn about it, but in Houdini, when you copy points, it aligns the positive Z axis along the normal of the point you're copying to. So these normals here, we're going to copy this line to this. And then P scale is an intrinsic value. So this, I did an attribute noise to create variation. So I could disable all of these. And now it copies the points here. And this randomizes a little bit the normals, which is just an attribute noise. If I can type correctly. Attribute noise, vector, and I set it to n. And then it randomizes the normals. And then P scale is a value that's recognized by Houdini intrinsically, and it defines for a few things actually, but in this case, copy to points is reading the P scale, and it is scaling, you can see down here, this line by the P scale amount on each point. We'll use P scale actually later for scattering our rocks. And there we go, we got that. And this function here was a vex function I used to multiply P scale by itself. So the values near 1, if I select up here, whoops, U to go up, the values near 1 are going to stay close to 1. You see, very, very close to 1, it stays 1. And then the values below, maybe 0.2, are going to get multiplied by themselves and become a lot smaller. So this keeps a few long pieces and more smaller pieces. And that's by copying lines to the points. Now the other way you could create geometry is by actually moving these points along the normals. So I could take this point here, I can view the point number. I could say, okay, take point 13, push it along its normal, combine it with itself at the origin, and then add a line in between those 2 points. So the way we do that is we need each point, and I'll show you right now. If I transform and merge, so what I'm going to do is I'm going to manually transform these points up, and then I'm going to merge them back. And what we'll see is that when I combine these 2 points, this point that was 13, it should be 34 down here. But we need a way to tell Houdini connect point 34 to point 13. And it's hard to do that when you're doing this kind of operation. Because for example, the order, if I hit Shift R, the order of the merging is what defines the point numbers on our points in this case. So in order to keep point numbers consistent for meshing them together, we want to tell Houdini some kind of identifying information that says, okay, this point 34 at the bottom belongs to point 13, this point 29 belongs to point 8, And the way we do that is with an ID attribute. Actually, the way we do that is with any attribute. So the case I did this, and I'll show you what I mean in a second, is I create an ID, an integer ID attribute called ID, and I name it point number. So right now, point 13, if I look at 13, we'll have ID 13. And then when I displace these, again, this is a mountain, so a noise, very similar to what we did earlier. I merged them together, and now you see, I'm going to make this smaller just for today's example. This point 10 is displaced to point 31, but if we look at our geometry spreadsheet, point 10 has ID 10, and point 31 should have the same ID. Okay, what's happening right now is I don't have my selection on the merge, so right now it's only looking at these points. If I click merge, now point 10 should have my, you see now I'm selecting merge, so geometry spreadsheet is showing the merge node. I'm going to sort points by their number. 31 has ID 10, and 10 has ID 10. And then I connect them with an add. And the way you do that is with an add node. You go here, polygons, and then by group, and then you add by attribute and ID. And it doesn't have to be ID. So for example, if I recreated this with a wrangle, I could say I at my, my super So I now create a new attribute, and I name it, or I save it, the point number value to that attribute. I transform, so I displace manually, but we could use a mountain. Let's do this, and let's rotate them. So these are the new points. I want to merge these together. And now, if I add, I want to connect. I'm going to disable these lines for a second. I want to connect the matching points based on my super attribute. So I'm going to copy that name, go into add, polygons, group, add, points, my attribute. And you can see it's connecting these in the point order. And we can close it to make a closed loop. But what we're going to do is by attribute, and we're going to type in my super attribute. And now Houdini looks up the value of each point's attribute, and it matches the ones that have the matching attribute. So ID is just commonly used, but you don't have to use it. So I'm trying to say that it is not intrinsically recognized. In this case, it could be anything. And then up next, I just showed you a switch node to show you that either way technically does create geometry. So next up, I want to displace these points and add a little wavy, but in order to do that, I need to have more points in between the two of these. So if I displace this point with a wavy noise, it wouldn't have anything because there's no points along this line to actually displace. So the way we fix that is with a resample node, and this is used a ton in Houdini. So I can set the length 0.02, and now it's resampling this line and adding a new point every 0.2 units. You can also do segments, so add 10 points for everything, but now we'll notice the short pieces have a higher density of points, but the long ones, there's more of a gap between. So because we want the segment length to be the same, we're going to do segment length. We resample, and I'll walk you through this in a second. We add a noise. We match the size to move it back to the origin, and then we set some width attributes. So the way we add the noise is we want to say, okay, Houdini, displace the top parts and not the bottom parts. And the way we can do that is we can create an attribute using the resample, which is a curve view attribute. This is another attribute in Houdini. So if I add a color type, grant from attribute, curve view, and if I change the base color to blue or to red and the top to blue, we can see zeros are red and blues is 1. So I'm going to use this color to mask a noise, which is similar to a mountain, And the way I'm going to choose to do that is with an attribute VOP. So an attribute VOP, or a point VOP in this case, it's the attribute VOP running over points, is a way we can do something very similar to Vex. So the two things are similar. I'll just jump inside to show you what's going on. But I read in the position, I create a noise, I add that noise to the object, and then I mix based on the curve view attribute. So that is a simple way to set it up. I might show you actually a different way to do it. I'll show, yeah, why not? I'll show you both ways. So to create this, we would do a point VOP, connect it here, and we want to take each point and we want to compute a noise. So we'll use an anti-alias noise. Give it a second. And we want to have a 3D noise computed for each point here. And then what we want to do is we want to add that noise to the position. And you can see we have this VOP, not yet, we do have this VOP selected. Inside, nothing is changing because we're not saving this attribute we're modifying. And in order to save that, we have to connect it to an output, or we have to bind, export it, which is a way you can output attributes that Houdini is not guessing that you want to attribute or you want to output. So we'll add to position, and now you see we displace our points to position. If I did bind export, set this to P, and you see now the issue is it's blending between the two of these because there's now two attributes being exported. But I'll set this to vector, disable this, and I'll connect it here. Yep, it looks like it's the same. So it's the same way to do it. When you're writing your own attributes, you would use a bind export, but when you're doing it with a VOP, you would typically be able to use these because these are the common ones you would use. So basically we import that in, but now we want to say only keep the top parts displaced and keep the bottom parts where they were. So what we need to do is we need to mix. And we want to mix two vectors. We want to mix the original position of our objects with this new position. And now if we combine these two, we can see we're mixing between these 2 points positions, but every single point is being mixed. So what we want to do is we want some kind of value that says at 0, keep it to 0 displacement, and at the end, keep it to 1 displacement. And the great thing is now we have curve U, which is exactly what we need. So if I did a bind, which is how you bring in attributes that are not here. So I want to say, hey, Houdini, get this attribute from my data, curve U, and then use this value, so 0 to, or I guess 1 to 0, 1 to the top, and use that as the bias. If I connect that, there we go. Now the points at the bottom stay where they are, and the points at the top get displaced. And on our noise, we can change the amplitude, we can change the roughness, all these different settings. And what we could also do is if we middle mouse button on frequency or on any parameter here, we can middle mouse and then release on promote parameter. And this is going to promote these parameters. So if I hit U onto this node here. So now I can change the amplitude, all these different settings for my noise. So that's exactly what I did here. I actually did a remap, so I'll show you what that is too. So I did a ramp parameter, connected it here. Another ramp parameters are very big in Houdini as well. I set it from ramp type RGB color to spline, and now it fixed it or reset it back to nothing, and I'll show you why in a second. But what I want to do is I want to take this 1 and this 0 value of curve U, and I want to be able to remap it with a parameter, a ramp parameter. So I hit U to go up. Now you'll see this ramp here. This says values of 0 for curve U, which are the ones incoming to this ramp, do some kind of remapping and then export that value up. So 0, right now it's setting it to 0 because that's the line here. 1, it's setting it to 0 because that's the line here. If we wanted to do what the default curve U did, we could do this. So it was 1 is 1 and 0 is 0. But we could also change it. So maybe we want the bottom to displace. Or maybe we want only the middle to displace. And then these we can shift select and move them around. So now you can see we're changing, oops, what part of the curve is being affected by this based on the curve view attribute. And in this case, I didn't actually use that. I just wanted it for control in the option to do it. And then I did this $F expression on my noise, and that was it. That was my plant. And then I used a match size, which we've covered a lot, to put it here. And then I displaced it with an offset. So I wanted it not to have any parts above the ground. So I was like, all right, well, maybe 0.02. So at negative 0.2 would be very far in the ground, but I want a negative 0.02 to be below ground. Then what I want to do is I want to randomize each of these blades, and I want to give a width to each blade. So if I wanted to sweep, which is a way to trace a curve and add geometry, I could create a sweep, add a round tube, and now we have this little wire of geometry. We can add end caps if we wanted. But what I want to do is I want to be able to make the bottom thick, the top very thin, and then I also want to randomize each one. So some are thicker than others and some are more thin. So the way to do that is I created an attribute class for each object that's connected, and now I use the connectivity. I created a width attribute, which was a random width that I set between 0.3 and 1. I remapped that along the curve U, which I'll show you again. And then I set a p-scale based off the width. So width, technically I didn't need. I could have just straight done p-scale, but I chose to do width. And then that gave me this, which is the thin at the bottom and thin at the top, but long in the middle. So to set that up, we need connectivity, which generates an attribute for each individually connected object. And we can name this to my grass blade. So my grass blade now has a unique identifier for every individual connected piece of geometry. I'm going to copy this name. I'm going to randomize a p-scale. You see it randomizes the color on each point, but I want the p-scale. And I want to set it as a dimension of 1, so I want to float 0 to 1. And we'll do 0.3 again to 1. And now I could actually connect it right here, and you'll see what happened. It randomized the p-scale, but for each point, it randomized a different p-scale. So if I set the seed to $F and scrub through, you see each random point is now its own p-scale. But what I actually want to do is I want to say, okay, for this grass blade, set a certain seed to keep it the same randomized p-scale across the whole blade. We can do that with the seed attribute. So if I paste this my grass blade attribute I created, there we go. Now I'll say for every grass blade with the ID or the number 16, randomly seed the p-scale. So every object along this one will have the same p-scale. If I delete that, it'll have random p-scale and put it back. And now if I want to keep the bottoms thin, or the bottoms thick and the tops thin, or even remap anyway, I could do a wrangle, which is actually what I did here, and I'll show you really quickly. So in order to do this, I'm going to template this bottom flag so I see what's going on, the sweep. And I want to get the curve view, and I want to get the p-scale, and then I want to remap the curve view and multiply that by p-scale. So the way to do that is I'm going to do f at p-scale equals, I'll say times equals mult. Mult doesn't exist yet, so I'm going to define it. Float mult. And that's creating a float for our variable mult. And now it's currently setting it to 0. If I wanted to see that in the spreadsheet, I could do at, I should cast it to a, and now that'll save it. And these two things are different. So this mult is different than an attribute mult. But for now, what I'm going to do, we actually don't need this, but that's just a way to save variables either locally on a Wrangle or on the actual geometry itself. So I can comment that out by doing that or just delete it. All right, a quick pause. I actually realized there's multiple ways of doing this, but the easiest way to do it would be to use the sweep node in the way that Side Effects has built it out for us. So I'm going to show you also how to do the same thing by a Wrangle and then also the same thing by a VOP, because that's helpful to know. But for now, what we're actually going to do is we're going to connect this to our sweep. We're going to set our surface shape to round tube. We're going to scale the radius, add end caps, and then we're going to scale along the curve. So this is a functionality that's already been built in, and we can apply the same thing, maybe shift select and set to B-spline. We can apply the same effect we have here, but without having to do it manually. So that's one way of doing it, and we'll get a very similar effect to what we had here, which was what we did manually. Now, if we didn't have this sweep node, or if we wanted to remap this variable for a different reason, we could do that with Vex or with VOPs, and I'll show you both of those ways right now. The first way we can do it is with Vex, and the way we can do that is we can take our p-scale in, which is this value here, and we can remap it by multiplying it by some kind of variable we create using curve view. So I'm actually going to delete this float. Well, I'll leave it there. But for now, I'm going to say mult equals f at curve view. And now what I'm doing is I'm reading curve view, storing it into mult, and I'm multiplying it by p-scale. And we'll see what happens now is we have thin at the bottom because it's a 0 curve view, and thick at the top because it's a 1 value for curve view. And since we're multiplying that by p-scale, that's scaling p-scale by that same amount. Now if we wanted to flip this, we could do a few things. Firstly, since we know p-scale is between 0 and 1, we could just do 1 minus curve view, and that'll flip it. And if that's what you want, you could just leave it there. But another thing we could do is I'll comment this out, and then I will do the same thing. It's now flipping it, but what I could do is I could remap it with one of these ramps. So this is the same kind of thing that Side Effects has built into this node, but it's helpful to learn how to remap attributes using Wrangles because you'll do this a lot. And you can actually, there is an attribute remap which does have this built in, but we are not going to use that because I want to show you how to do it with a Wrangle, because in my opinion, it's better to do it with a Wrangle because then you know exactly what's going on. You could also do the remap if you want to. So get the curve view in, and now what I want to do is I want to create a ramp, and I want to set the value of curve view, actually the value of mult will remap, and I want to set that based on the ramp. So I can say mult equals chramp, and let's say remap our mult, and this will be the name of the map, or name, excuse me, of the ramp that will be created. And now what value do I want to remap? And the way I can see this, I'm going to copy. If you type in a function, you can either look on the documentation or a little helpful thing comes up when you have this first parentheses open. So we pick a channel, which was a string, which is the name of what we want to name our ramp. And then we pick a float, which is the value that we want to actually remap. So I'm going to say remap our molt. And now what do we want to remap? We want to remap molt. Then we close bracket and we use a semicolon. Now, nothing happened because we have to click this button here, which will create the spare parameters. And there we go. Now we have a ramp that remaps. So 0 here is remapping to 0, but we could remap that to 1. And we could remap 1 to 0. Or we could do anything along the way. So I'm going to select these three and I'm going to set it to B-spline just because that gives a little more of a smooth interpolation between the points. So again, you're welcome to do this with a sweep. You could do an attribute remap, which has this functionality built in. I won't show you how to use this because I actually don't really use this node. I do everything with a Wrangle because I think it's more fun to write code. But now let's show you how to do it in a point VOP. So a point VOP and a VOP are similar, except a point VOP's set to run over points, and it looks like a VOP by default is also set to run over points. But you can do VOPs over you can do VOPs over points or over primitives. And the same thing here for Wrangles. You could write a Wrangle that runs over primitives rather than points, which lets you access the data on the primitives. In this case, we have none, or the points. So now what we want to do, whoops, I don't want to connect that there. And these, I'm not going to dive too much into VOPs and Wrangles because there's plenty of content online that is great stuff for showing those. What I want to show you quickly is a setup on how to model these and use these, and then we'll get into more of the layout for environment and the rest of the stuff. So inside our point VOP, what we want to do is we want to take the same thing. We want to somehow remap this bottom and the top and define a p-scale. So to do that, what we're going to do is we're going to need to read the p-scale in before we can adjust anything. So I'm going to bind it and I'm going to read it in. Now, whoops, U to go up. I'm actually going to connect this sweep node so we can see what's going on. Now if I did a bind export here and I save out p-scale, I want to connect and see what's going on here. So if I say float, well, let's do a multiplication. Let's take p-scale, multiply it by constant, which we can do by creating a constant. Let's multiply it by 3, oops, 3, and then we'll export that. So now we're taking in p-scale, we're multiplying it by 3, or in this case, any constant, and we're saving that back out to p-scale. But what we want to do is we want to remap this based on curve U. So we could also do curve U, which, you see, I just typed that there. We can't actually access attributes like that, so we have to do another bind. I'm going to alt drag, and now I'm going to type in curve U, and then I'm going to multiply this curve U, which I'm going to read from here into our multiply, and we'll see it had that same functionality as this here. So here, to access on a Wrangle the attributes, we do the @ sign. Inside point VOPs, we have to bind, and then we have to export and bind export. I might do a mini series on these later, but most likely not. That is not planned. So curve U, what we want to do is now we want to remap it. So we can do ramp parameter, and we want to remap that, and we want to remap not a color. We want to take a ramp type and set that to spline. Now nothing is going to, we're just going to change to nothing because we have to go U to go up, and now we can adjust our ramp. So this is the way to do it with VOPs. I'm going to set these to B-spline. This is the way to do it with Wrangles, and then this is the way to do it with a sweep node. So 3 ways. There's probably also a bunch more ways, which is the cool thing about Houdini, but you're welcome to choose whichever way you want. There's actually a 4th with an attribute remap, which I'm not going to show you. So here we get our sweep coming in, and I changed the columns to add different resolution here. And I actually wanted a square tube because I thought it'd be low poly, but I think it's fine if we add a few extra pieces of resolution. So I'll put it back to round instead, and I'll make it maybe 10 columns. So we can see nice little smooth rounding. Then what I wanted to do is I wanted to blur a little bit at the positioning to make it smooth, which is just done with an attribute blur. And you can see that blurs the position of the objects. And I'm now blurring by connectivity. You can blur by proximity, but connectivity is what I wanted. And then a normal to compute the new normals. Transform, I rotated it along the positive z-axis, so that's the up. And then again, all of these are randomized, so I have to time shift. And now I save a single one to disk, which we've already done, and I'll do again. And there we go. Now we've got a nice little plant that's static on every frame. And now we can export that later and fetch it from here to instance into our layout. So space G to reset. And that's a quick example of how to do it. And as you can see, there's multiple ways to do this, multiple ways to do this, really multiple ways to do everything in Houdini, and understanding how these attributes work. One more thing actually, a way to preview attributes is with color, and I do it a lot. Ramp from attribute, and I'll select the attribute you want to preview. And the black I don't like because it's dark on the background. So I usually change that to red, and then blue is a really easy thing to see. But if you hit D and had a light background, then you might see the black a little better. I prefer with the dark, so you can choose to work however you'd like. But this is a great way to remap the things in Houdini. You can see that's even an integer attribute. So remember this connectivity we made? This connectivity was an integer, which was 0, it looks like, to 21, because we have 21 points that we scattered. If I middle mouse button, looks like we have 22 points actually, because 0 to 21 is 22, because the indexing starts at 0. But what we have here is an attribute, which is an integer, and what we can see is we can remap this from 0 to 1 to 0 to 21. And now that integer attribute is getting colors based on the value here from the ramp. So if we did any kind of remapping here we want to do, we can choose that, and we can have attributes, store these attributes, and then when we randomize these, you can do pretty much all sorts of things with this. So we can even split out the purple ones and maybe add leaves to them if they have a certain random number. Or if we wanted to say for the really tall ones, we can make them have an extra branch along. And we can do that by measuring it, maybe duplicating branches from here, spreading them out. There's lots of things we can do. And as we get into more advanced setups, we'll probably do some more of those. But those might be procedural lightning effects, using similar ideas of creating curves, creating attributes along curves, and then remapping attributes to do different things. So that'll be it. And then that looks like it's all of the lesson topics we need to cover for this video. So that's a basic modeling of the rock, the stone paver, and then the grass plant. Awesome. Well, that'll be it for this video. We'll go into the next video where we're going to continue modeling. And then this is a little bit longer than I was expecting when preparing these lessons, but I think going through node by node is the best way to learn. So I'm hoping that you all appreciate the detail. And if you do want to just get these files and jump ahead, you are more than welcome to, but hopefully you really have an understanding of what's going on rather than just placing nodes and following someone blindly. So awesome. Thank you. And I will see you in the next video.